Show of hands, how many of you are interested in being a biomedical engineer someday? All right, you guys are probably going to love this presentation. The rest of you, please bear with me. I've got another question, though. How many of you want to be an astronaut someday? All right, a few more hands, good. You'll learn a little bit about this too. So this presentation kind of goes in both directions. It starts off with our astronaut selection process, so you get a sense of how we select the astronauts, and then from there it goes into sort of the biomedical concerns that crew members deal with in space. A little bit about myself, you guys heard I'm acting associate director at Johnson Space Center in Houston, Texas with NASA. I started out, I have degrees in aerospace and mechanical engineering, and I was initially a spacewalk expert for my first 10 years at NASA. I've been with NASA about 30 years. So I used to plan spacewalks, train the astronauts, and work in mission control. I was one of the folks that worked on repairing the Hubble Space Telescope. I helped initially build the International Space Station, and I've been in a number of management positions. Some of the interesting ones, particularly that pertain to this subject, is I was chief of space medicine operations. So I actually have had all of this sort of area under my purview at one point in time or another. Another thing I want to mention, back when I was a spacewalk expert, I worked on STS-87. So I actually, that was a spacewalk where we had to capture a satellite. We had a number of other things, and I largely worked with two astronauts who were the spacewalkers on that mission. But Leonid Kidenyuk, did I say that correctly? All right. In Texas, we wouldn't say it like that in Texas. We would mess up the pronunciation. But I actually worked with Leonid back when he flew on STS-87. He was a great astronaut. Appreciate Ukraine lending him to us back in those days. I understand he passed away this year, so condolences to him, but I wanted to point out thank you again for loaning us a great astronaut when we could have him. So a little bit about astronaut selection. 350 folks in NASA's history have been selected to be astronauts. Since 1978, we've gotten almost 65,000 applications for the astronaut candidate program. So if you do the math, you've got about a 0.42% chance of making it. I myself did not make it. I applied a number of times to be astronaut, and they said, actually the chief of flight operations came and put his arm around me and said, Mike, your job is here on the ground helping manage NASA, not in space. So I got the impression it was my last, that's the last time I needed to apply. But there have been 212 astronauts selected from the military and 138 civilians. And just from the military standpoint, the U.S. Air Force has 85 with the Navy not far behind at 83. So the recruitment process works. Recommendations for recruitment come through our Flight Operations Directorate at NASA. And that's based on how many astronauts we need, how many have retired. You know, there's always a few that are retiring, and that really, we had a lot of them retired right at the end of, when we finished space station assembly, and we finished the space shuttle program, a lot of them retired. So we generally pick a new class every 3 to 5 years. I know, and the basic qualifications, so those of you that want to know how to be qualified, here are the basic qualifications. 4-year degree in science, technology, engineering, or math, some sort of a STEM field from an accredited institution, a minimum of 3 years of technical work experience after you finish that bachelor's degree, and U.S. citizenship, unless you're in the European Space Program or one of the other programs that chooses someone from another, maybe your local space program would choose you, and then you would, through a cooperative agreement, fly with NASA. That's how other folks have flown. Now, those are the minimum requirements. Having such a large number of applicants, generally the people that we choose have much more than those basic minimum requirements on their resume, but that's the minimum you need. So in the last time we did astronaut selection, which was in 2017, we received about 18,000 applications. Of that, we went through and whittled it down to 11, almost 12,000 people who were qualified 440 of those became, after review, the highly qualified candidates, and at the end we selected 12 to be astronauts. During that year we had 11 weeks of interviews. 120 people had first-round interviews, and 50 were selected for second-round interviews. And so what's interesting, the 6,418 not qualified applicants, which is about the same percentage in every application cycle that we have. So it's almost the same amount of not qualified people. There's a lot of people that just apply just to get the NASA rejection letter because they want to frame that on their wall or want to keep that and say, look, I was not selected as astronaut. Mine is in the bottom of a cabinet at work, but it's there. I haven't framed it yet. All right, so a little bit about our review process. So we had a number of human resource professionals. There was a lady I met here who's human resources. All right, very important to the astronaut selection process are our human resource professionals. So we had a whole bullpen of human resources people from across NASA that went through to determine whether the basic qualifications were met and broke the applications into different discipline groups: pilots, flight test engineers, biomedical and mechanical sciences, physical sciences, and engineering and operations. And so they look at all the qualified sort of degree programs that come from that. Then we had a rating panel. We had almost 50, it was between astronauts and senior management officials that served on that rating panel, and they looked at who would be the highly qualified applicants of that bunch, and they were reviewed by each discipline group. So by picking, some people actually fit into more than one discipline group. We've had folks who are a pilot and maybe have 2 PhDs, maybe have one in engineering and one in science, or even are an MD and a PhD. So you would imagine we get some very highly qualified candidates. And then we came down to the 440 qualified applicants, which were forwarded to the selection board, and we did over 2,000 reference checks to make sure people were accurate about their achievements. Some people tend to stretch the truth a little, and we want to verify that. So our astronaut selection board determined the 120 people who were picked for interviews. This board had 15 folks on it, some of which are here. 11 of them participated in the first round, 12 participated in the second round of interviews, and this group of people, just looking at here, there's flight operations management in that picture, the chief of human resources, several flown astronauts, and my counterpart from the Kennedy Space Center, the associate director of Kennedy Space Center there. And of course, right in the center there was a gentleman who was, at that time, he was the chief of the astronaut office, was also involved. So a lot of management review and experience to go into this. So a little bit about these interviews, and this is where we're going to start to give you the flavor of the biomedical engineering piece of this. So we had our first round interviews. We used some Skype technology for people who couldn't make it. We actually had a candidate that was stuck on the South Pole. They get the notification, we'd like you to come to Johnson Space Center for an interview, and in this case, the person's like, can't do that. I'm stuck down here and can't get off the ice. So we did it by Skype. So, doesn't matter where you are, we can make it happen. We had 50 candidates back for our second round interviews. Now, the second round interview is where things get interesting. This is where we started to have our psychological, behavioral, and medical testing. So the biological portion of the tests, most of these sorts of tests occurred during the second round interview. So what are we doing medically? Well, you want to make sure the person is at least baseline medically qualified. They have equal strength on both sides of their body. They have all their organs. They haven't had surgeries on themselves that make them disqualified. So those sorts of things. And then we also do some behavioral type testing to make sure they're going to work well as a team, that they're going to work in the environment. It's high stress, so we want to make sure people aren't going to, kind of get panicky, those sorts of things. So over the course of the selection cycle, we had a total of 616 individual tests and activities completed with the applicants, leveraging folks from 23 institutions at Johnson Space Center and around NASA. Some of these additional activities included team reaction exercises, individual performance exercises, tool exercises, and an extravehicular skills test. That's spacewalking. So this is actually, looks kind of funny, and I attended this test. This was actually one of the sort of, it's a team test. It's sort of like a ropes course for any of you that have done a ropes course, but the astronauts are given a problem. Say in this case, they had to cross over a boundary using just a few tools, boards and wheels and a suspended tire, and had to get from one side of something to the other. And we were looking at their team dynamics. Were they cooperating? How are they innovating? Those sorts of things to see how they could, on the fly, solve not a very difficult problem, but how do they work together as a team? And so they were each individually scored. And then down in this picture, you can see some of the extravehicular activity testing. This person's actually in a harness, helmet. They're doing, as if they were doing a spacewalk task, they're suspended on a system we have called POGO. It's a partial gravity offset system, so they can actually move their body around. It's as if they're floating in space, and we can see how they're doing with regards to tool use. Very often, you may have someone who is an absolute genius, PhD, or physician, but maybe they aren't very good with tools. Well, we need people, or even a pilot, who may not be good with tools. We want to see what is the mechanical aptitude of our astronaut selectees to determine, can they fix things? Are they able to work with wrenches? Because everything on space station, inside and out, has to be repaired. And you want someone who has some baseline amount of mechanical aptitude, and they have to be able to do things in a really weird environment and get used to kind of supporting their body and offsetting loads with the other hand, because in zero gravity, every action has an equal and opposite reaction, and you'll go twisting your body around in ways you didn't expect. Okay, so we got down to actually selecting. We selected 12 people. Turned out, and we didn't have a plan for how many men, women, military, non-military. This is just how the data fell out. So we don't have any quotas for anything, but we ended up with 6 military people and 6 civilian, and they were comprised of 5 women and 7 men, and we had all the different discipline fields represented. Now that's one thing, you would like to see someone from each of those discipline fields represented in a class, so you have a very diverse set of backgrounds. You just don't want to pick all pilots. You want a very diverse group. So we had 3 pilots, 1 full-time NASA employee who had worked at another center, 3 biological or medical scientists, 2 of them are physicians, I know that, 4 engineers and 1 physical scientist. And their bios, I've got their website if you want to look at some of their bios, but really impressive group of people, and we're glad to have them on. So they came on board in June of 2017, and we had a big fanfare announcement to announce these folks with a live view of the announcement event with social media and those sorts of things. So it was very exciting to announce them, because these are going to be some of the folks that are going to go up on some pretty difficult missions in the future. We'll talk about that in a little bit. So what do they do next? All right, they all reported to work a little more than a year ago on August 21st of 2017, and they will undergo a 2-year training program. So as astronaut candidates, once they're done with astronaut candidates, they are assignable as an astronaut to a mission. But this 2-year generic training includes systems training on the space station systems. Things like, how do you work the life support system? How do you repair the life support system? How does it work? The robotic system. Can you operate the robotic systems and be basically trained in that? Extravehicular activity. How do you do a spacewalk? So they get their first 4 spacewalks in our water tank underwater, they get measured for the spacesuit, they do initial training, and then they do some advanced spacewalk training. Because the station we have Russian elements and modules, they go through Russian language training, and then through T-38 flight training, that's the trainer jet that we use at NASA. And when they're completed, they could be assigned to a mission. Our next class announcement, probably anywhere from 3 to 5 years. I would imagine it'll be about 2 years from now we'll make the announcement, and about 3 years we might make the selection, but that's a guess. So you see some of the basic, they're giving their thumbs up and all that sort of thing, but this is some of the types of training, the flight training and the spacewalk training that they go through, and they get ready for assignment. All right, so they're done with their 2 years training and they get assigned to a mission. That's where you start about a 3-year mission-specific flow. So you would be assigned initially as a backup crew person, and then as a prime crew person. So you end up being prepared for a mission as a backup crewman, and then as a prime crewman. And you go through even more training on what will happen on your specific time on space station. And a lot of training on how to launch and land in the Soyuz, because everybody has a job with that. And that's our current way of getting people to and from space station. Now, what do we do with regards to space medicine operations and biomedical engineering? Well, the mission of that organization is to advance and protect the health and well-being of the astronauts and, of course, the NASA Johnson Space Center workforce to enable the human exploration of space. How do we do that? Well, we're divided into a couple different areas to look at this. One of the main ones is our space medicine department. And in that, we do the real-time mission console support to verify astronaut health, performance, and wellness. So we're doing checkups. We have a flight surgeon and a team of biomedical engineers that monitors the health of all the astronauts that are on board, and they do medical checkups routinely, determine how they're doing medically, and how they're doing on their exercise. We do a lot of pre-mission launch landing and treatment. So part of that's kind of like sports medicine to get them ready, to get them in shape. We do medical support for the everybody who flies on the aircraft, and then all of our training for the hazardous facilities like the water tank or vacuum chambers. And we also have a behavioral health department that manages and monitors the astronauts' behavioral health, making sure that that's healthy, working with their families, working with their teammates. We have a group that does occupational medicine, clinics and laboratories at the Johnson Space Center for the employees. They also support the astronauts and test subjects. And then we also have institutional occupational health, looking at things like asbestos and radiological materials and handling. So now let's talk for a second about our human spaceflight operations and how we do this. So there's sort of the mission medical operations wing of this, where we have our biomedical engineering support to all the programs. That's the space station, Orion, which is our capsule that we're building to go back to the moon, and commercial crew program. Those are the capsules being built by, say, SpaceX or Boeing that will be commercial and fly astronauts to space station. We help work with those companies and those other entities to make sure that their vehicles are designed medically and psychologically to take care of the crews that are going to be in them. We do the real-time console operations and mission control, monitoring these sorts of things, and we do all the planning and training of events. So you would imagine on space station, all the astronauts get some basic level of medical training in case somebody gets sick. So they all have to be trained on all the medical gear and how to use it. And the flight surgeons are in that area too, and they're really the one that's in charge. But the biomedical engineers do a lot of the detailed work and the training. We also have a space radiation analysis group. And we've talked a little bit today about space radiation. These folks are actually doing real-time weather monitoring of space to see what the sun is doing. And the astronauts all have their active and passive radiation dosimeters, so we can figure out how much radiation dose each of them gets. You get more when you go out to do a spacewalk, and we monitor that. There's even, if you're out doing a spacewalk and the space station passes through the tilt of the Earth near where the Van Allen belts dip down, that's called the South Atlantic anomaly, you get an even little bit more radiation. Not a lot. It's equivalent to getting an extra X-ray almost every day, but that through time can build up. And we have a radiation limit for an astronaut that you can only get so much dose across your lifetime. And then you're done flying, because that's sort of, for radiation workers, it's a given level, and they're actually exposed a lot more than we are. And we also have our medical projects group for space station that trains people on whatever medical evaluations are going to go. So if there is any new experiment that would happen during an increment, those folks are working with the PIs, the investigators, on how do they want to try and do the test, and training the crew and making sure that when it occurs, they're getting the data back to the scientists so it can be evaluated. All right, crews are on board. Once you're on board from a biological or biomedical instance, one of the big things each astronaut has is a couple of hours of doing exercise countermeasures to your body's changes in space. And I'll talk briefly here in a minute about those changes, but from a cardiovascular standpoint, you have Sunny Williams here on your left. She's running on our treadmill, just to keep our cardiovascular system going. But then we have Dan Burbank on the right over there, and he's actually doing resistive exercises, weightlifting, squats, those sorts of things. It turns out we were seeing astronauts coming back with significant bone loss in the early part of space station from these long duration missions. But by having an exercise prescription for them, we've actually counteracted that. They have very little bone loss while they're in space now. They come back with good muscle tone. They may have just 8% worth of bone loss within 6 months or so, sometimes even less than that, and it's all because of the exercise countermeasures that we do. I mentioned a lot of the onboard medical checks. So on the left here, we actually have an astronaut who is a physician. That's actually Tom Marshburn, and he's using the ultrasound to check the carotid arteries of Commander Chris Hadfield. Chris Hadfield's Canadian astronaut who was on board. Canadian astronaut program selected him, and he flew as one of the partnerships with NASA. Great guy. All these folks are great guys. And over there on the right, you've got Scott Kelly and Mikhail Kornienko, who is also one of the one-year crewmen, and they're doing an ultrasound on themselves. I talked a little bit about, we did a lot more medical testing on Mr. Kelly there because he was in space for a full year and he had a twin on the ground. So we were able to compare the difference between his brother Mark, who was on Earth, and him in space. And we saw there was no change to his genome, but we saw about 5% of the ways his genes expressed. So genomic expression, we had about a 5% change of the types of ways his genes did things. And that could come back to normal, but it was a difference between pre-flight and post-flight. So it's very interesting data that we're getting back. Oh, that's Gennady Padalko over there too, also running the ultrasound. Now let me talk briefly about the medical risks. I talked in my earlier presentation about the human research program at NASA, HRP. And the HRP really has about 5 big medical risks that we have to manage, but these all are broken down into sub-risks, so we have somewhere in the neighborhood of 30 overall risks. But the big ones being reduced gravity. Living in reduced gravity takes a toll on your body. So those exercise countermeasures are the biggest way that we use to counteract the effects of zero gravity. Another one is living in an isolated and confined environment. That is a behavioral component. Anytime you're locked in a small volume with a small number of other people, you don't want to get on each other's nerves. You want to operate effectively as a team. You want to work out differences. And so working together and living together in such close quarters is a big, huge risk. I mean, especially if we send people away to Mars, they've got to get along and work together as a team for 2 to 3 years on that sort of a mission. Another risk 3, is a hostile closed environment. When you're locked in a small environment such as space station, there are changes that happen because of that environment, including microbes on board space station become more virulent. It turns out your bodies immune system actually gets suppressed. So you've got microbes that are worse, and your body's means to counteract them is not as good. So you've got to worry about that. Also, medication stored on board for a long period will degrade. All of us, when you get medication from a pharmacy, there's an expiration date, but up in space, you're having that medication bombarded by radiation. And so we actually have, long-term use of medication in space is in question. Do we need to store it in lead-lined boxes to keep it effective if we go to Mars for a long-term mission? Also, onboard space station, you are exposed to more carbon dioxide. We have scrubbing systems, but you're breathing more CO2 in the space station than you would here on Earth. Generally not a problem unless it spikes up. Then you could have people complaining of headaches, and that might be if they're working in a confined area on something. They might have to set up a fan to help blow the breeze around and not have too much CO2. But what are the effects of higher CO2 dose over a long period? That's another risk we're looking at. Of course, we've talked about radiation, shielding, dosage, and the increased cancer risk that could occur from long-term duration. So Bill Shepard, the folks that flew first on space station flew about 19 years ago. And so we're right at the precipice of starting to look at, all right, might they get different diseases, cancers, loss of bone density, osteoporosis? Could they have these sorts of disease processes that are caused by space? We're still reviewing that. We do an annual study of all of the astronauts who have flown to determine, has their body changed? Now, what's really interesting is, technology has improved so much recently. We have MRIs and CT scans that you can go down to a much more detailed level than we had even 20 years ago. So, especially with Mr. Kelly, we were able to significantly image him before his mission and after his mission and look at things even like, did the back of his eyeball globe flatten? I mean, and we're seeing those sorts of symptoms among some astronauts that come back. Their vision is actually getting worse the longer they're on space station. Now, not much, very, very little, but it's noticeable to them. And in the past, we may have said, oh, you're just getting older. You're almost 50. Your vision goes bad. Well, now we can image it, and we're realizing, no, it's actually space flight that's causing that. It's not just the age impacts, because you were seeing zero gravity changes to some of the inside, right behind the eyeball, some of the geometry back there. So these are things we're studying. And the last one, if we go further and further to Earth, the risk of needing to be self-sufficient. Of course, on space station, you're somewhat self-sufficient. You're locked up in this can 200 miles above Earth. And you have generally two-way comm almost all the time, so if you have a problem, you can call the Earth. But if someone gets profoundly sick, you may have to take action there quickly, and then you might have to evacuate them. But if you're on the moon, you're talking like you're 2 days plus from home. If you're on Mars, you could be a year and a half from home. So having to work medically self-sufficiently is another problem that we're dealing with space flight. All right, crews come back from space. A big piece, we do a lot of studying when they've come back. There is their pre-mission medical checkup. We do a lot of medical testing and sample collection during the mission. And then when they get back, we do a lot of comparison studies. And then they begin their rehabilitation. They're not allowed to drive for about 2 weeks. Their vestibular system is really not there yet. But they go through a significant amount of rehabilitation, swimming, some amount of weight training, but in the beginning it's just walking, just learning to walk without losing your balance sort of things. So, but when they come off of the vehicle, they're pretty wiped out. So there's a few days there where they don't even really want to stand up. Okay, the ultimate goal, we've talked about this before, especially with Dr. Zubrin's presentation. The ultimate goal is humans on Mars. All of what we're learning right now on space station is paying forward to future human exploration so that we can get onto the red planet and learn how to operate. Now, we don't want to end up stranding someone like they did in this movie, The Martian, with Matt Damon. We want to make sure we've got all these things figured out so that we don't have an emergency like this, so that we have backup systems, and that sort of thing never happens. But these are the sorts of things we're working on in human health and performance at NASA. Let's go down here. All right, so how am I doing on time? Pretty good? Good for questions? Let me mention a couple things here at the end. So those of you that want to look at how we're doing or what we're up to at NASA, I've included here, our Facebook for the International Space Station, for Johnson Space Center, our commercial crew program, our Orion spacecraft. The Orion is being built to return to the moon. These commercial crew vehicles are the human-rated vehicles from Boeing and SpaceX that are about to start trips to the space station in the next year or so. And then we've got Twitter feeds for all of those. Lots of interesting things get posted. And Instagram, some sites that you might find interesting. All right.
Okay. Thanks, Michael.
Thank you.
Yay. Okay, є питання?
Yes. Yes. So, yeah, in mission operations, in flight operations, we're the mission control team. And there were many times where a shuttle or space station would call down with a problem, and we'd pull together a Tiger team to figure out and solve the problem. Sometimes it had to be in real time, especially on STS-87. We had a satellite that had come loose, and it was spinning, and we couldn't grab it with the robot arm, and we had to figure out how to have two astronauts grab it and berth it in the payload bay. So sometimes it gets pretty dicey, but we've been successful.
Okay. Итак, перше питання, тоді go.
Здравствуйте. Я хотел вам задать вопрос, как астронавты разбираются со своим телом? Ну, то есть, как они моются, как они бреются там, и так далее.
We don't have a shower on board the space station. They use just a washcloth you spray some water in it and use soap and just wash yourself off. So it's like a sponge bath, or they use just wet wipes, like what you'd use for a baby or whatever. So that's what you're using to clean yourself, your body, and you clean yourself every few days. Shaving, usually either you're using an electric razor, so all the whiskers and everything get trapped inside the housing of the razor, and then you can clean that in a trash compartment, so all that stuff goes away. Usually get it a little wet, so it doesn't, you don't want to breathe in or get whiskers or those sorts of things. Or if you're using shaving cream, then it's trapped in the gel, and you just put that in a wet trash container and wipe it off with the wet wipe. Restroom. So going to the restroom is a pretty windy affair. So when you go to the restroom, you turn some valves, and because there's no gravity, everything would stay attached to your body. So it has to have some sort of flow to pull things away from your body, and then that's captured in a can, basically, a waste containment can. Now, what we do with liquid waste gets put through our distillation assembly and becomes fresh water again. So we recycle about 87 to 91% of our water is recycled. And then solid waste is just captured, and that gets sealed up, and they put that in a Progress vehicle or another vehicle, and it burns up on reentry, and that's that. I hope that answered your question on those issues.
Окей, наступне питання.
Could you tell us a little bit of your story and how did you get into the space exploration and NASA and stuff?
Sure. My particular story, so I went to the University of Michigan and applied while I was in college to NASA's internship program. It's now called Pathway Interns, and got accepted into that. There again, it's about like that astronaut selection process. There's students from all across the US that apply to get into NASA. You have to have good grades and recommendations and work on some neat projects. But I got into NASA, and so from about my junior year on, I alternated semesters between working at the Johnson Space Center and then going back to the university to finish my bachelor's degree. And NASA generically assign, the way they work it at Johnson Space Center, and by the way, there's 10 NASA centers, and all of them have this pathway intern program, or in different types of internships. And so I did 5 of these pathway intern programs. I worked in, I was a propulsion engineer, and then I moved over and worked in spacewalking, and I was hooked. I really liked spacewalking because I got to dive in the water tank, fly in zero-gravity airplanes, work in mission control. It was like, I can't believe I'm getting paid to do this stuff. And it was so much fun. So I did my last 4 co-op tours there and got hired on permanently as a spacewalk person. And then that was my career for my first 10 years as a technical person before I went off into management. Now, a little bit about this co-op program or internships. So most of those NASA internships are only open to US citizens, but I know Jet Propulsion Lab and Ames both have a tendency to do more international, they have international internships. So if you look on the site, on the NASA site, there are occasionally international type internships that you can look for there to get in and start working with us. Hope that answered your question.
Well, it's really fascinating to see a launch of a spaceship. I'm wondering how much NASA is showing in real-time launches and operation in space on the ground, and how people in Ukraine can see it.
We have a NASA channel on that. You know, most in the U.S. I think it's webcast also. Whenever we're showing what's on the NASA channel, and that goes out to normal U.S. cable television providers. That's like real time. That's downlink direct from the space station for what the crew's doing. And so usually, mission control is normally looking at one of those views. But the NASA TV generally just, it's a public affairs officer that picks which view is going on, and often you're seeing raw downlink footage from the space station of the crew doing some experiment, or they might switch over and show what the crew in mission control is up to. Often, the crew sets up a camera and maybe they're in some little cubby hole doing something, and the view is not good. It's the back of someone's ear, and so that's usually when the public affairs officer switches to the mission control view rather than the horrible view from space station. But yeah, generally it's just raw live footage. Now there's times where the crew might have a private medical conference or a private family conference, or be doing a public affairs event, for some other, like pre-recording a greeting to some event or something. And so that's usually they take the TV off of space station and let the crew do those private events, either for private purposes or to be pre-recorded. But yeah, and then there are times, it's not often anymore, but usually we have two-way TV. We have KU band, but sometimes we either, the antenna gets used for a different purpose. NASA's just one of many users of those satellites, and if we're not a high priority and we can get our data through an S-band link and they don't need video, then some other user can use the KU band. So there's times where we get bumped.
Okay, I think
one more question. Thank a lot for your presentation. My question is about the soft skill.
Можете трошки голосніше говорити?
What soft skill must have the candidates to be preselected? What soft skill must have astronauts after selection? What skills you growing up during the preparing program? And what place in this list of soft skills have such skills as cognitive flexibility, creative thinking, etc.? Thank you.
Sure. So the soft skills, right? He's asked. Okay, so the soft skills. I mean, really, it gets down to, you could have a person who is the best fighter pilot or a super researcher, but they've got to be able to get along with other people and not maybe have an ego where they, someone else makes a recommendation and they just are like, yeah, whatever, we're doing it my way. So they look at how, are people good at interrelating with one another? Are they able to empathize? Can they tell when one of their other crewmen is not feeling good or hurting? Because when you get into space, you get space adaptation sickness, and you're not feeling good, and someone's performance can be impacted by that. And you want to make sure that there's some amount of empathy there, and you're going to help your fellow crewmen. So those are kind of the soft skills. It's really interpersonal relationship things. Now, once they become selected, they get training in all the systems, but you may actually specialize. Like there are some crew members that specialize because they're better at robotics. They might be like, okay, you're going to be a robotic operator. And then there's other ones that are really good in the spacesuit, and it's like you're going to be a spacewalker. But they've all got to generically be good at those skills to be able to shift. If the spacewalker has a cold or an earache one day, they might not be able to go out, and you've got to choose a different person to go. So everybody's got to be somewhat cross-trained, but once they're in space, you might have some specialty sort of specialization within the generic skills. Did that answer all the parts of the question? Okay.
Почему НАСА и Соединенные Штаты ждали так много времени после завершения программы Space Shuttle и не подготовили вовремя свою пилотируемую программу, вот только сейчас приступают к ее реализации?
The Space Shuttle program ended. This gets into policy. So NASA itself implements whatever policy the folks in the government, the US government, decide. And for when the space shuttle ended, the policy, we had one initial policy where we were going to accelerate that Orion vehicle and use that to go to space station. But that policy was changed, and the Orion is only going to be used for beyond low Earth orbit exploration. So its heat shield and the way it's built is optimized to go beyond low Earth orbit because it's different design constraints. And so what they did is they put out a proposal to all of the commercial industries in the US to start first with resupply, so unmanned resupply missions to the space station, and then to eventually fly commercial crew vehicles. And two companies did the commercial resupply. Those were Orbital ATK, which is now owned by Northrop Grumman, and SpaceX. So those were the two unmanned resupply vehicles, and they've been going on. And once we got confidence in those vehicles, there were other companies. We opened it up and said, okay, who wants to try crewed vehicles now? Because we wanted to make sure we understood fully and had several years worth of confidence in it. You don't want to jump into something as difficult as crew operations, crew vehicle operation. So there's two companies that are trying to do the crew missions. That is Boeing. They have their CT-100, and SpaceX with a crewed version of their Dragon. So it's just taken them that much time. I mean, there were milestones in the past, but it's a very complicated process. So it's just taken till now.
Дякуємо за питання.